Figure 13.8 shows a plot of PV by T versus P. Here P is the pressure, P is volume and T is temperature. So a plot of PV by T versus P for 1.0 into 10 raised to power minus 3 kg of oxygen gas at two different temperatures. So given हमें एक प्लॉट है between the PV by T, this quantity, versus the pressure for the oxygen gas at two different temperatures T1 and T2. So हमें प्लॉट की गिवन है T1 टेम्परेचर के लिए ये प्लॉट है and T2 टेम्परेचर के लिए ये प्लॉट है. So question is, what does the dotted plot signify? So for the ideal gas, अगर मैं किसी ideal gas की बात करूँ, we know PV is equal to nRT. This is the equation of state. So PV over T is equal to nR. So simply, or in a simpler manner, we are given a plot of nR versus the pressure, where n is number of moles, and R is the gas constant. So for an ideal gas, the value of nR should be constant for all the values of pressure. So this dotted line represents the ideal behavior of oxygen gas versus pressure. Okay, so we have answered the part A, and the answer is this shows the ideal behavior. Since nR is a constant quantity, so it will be constant for all pressure values. All pressure values, it will be some constant quantity. Which is true, T1 greater than T2 or T1 less than T2. Now question पूछा गया है कि टेम्परेचर T1 बड़ा होगा T2 से या फिर T1 छोटा होगा T2 से. We know that अगर पार्ट B की बात करूँ कि एक रियल गैस मेरी आइडियल बिहेवियर शो करेगी at high temperature and low pressure पर. So this curve is getting more and more similar to the ideal behavior rather than this curve. ठीक है, तो T2 टेम्परेचर पे कर्व है वो लेस आइडियल बिहेवियर शो कर रही है एज कम्पेयर टू द कर्व एट द T1 टेम्परेचर. सो टेम्परेचर T1 should be greater than temperature T2. This is the correct answer. Third question is, what is the value of PV by T where the curve meets on the x-axis? So for an ideal gas, PV by T is equal to nR, where n is the number of moles of the gas. So this value where all the three curves meet is equal to Ah, okay. In the given case, so this should be number of moles of oxygen gas into the gas constant R. So we have answered the question C as well. Question D is if we plot similar plots, actually we can also calculate the numerical value. Number of moles of oxygen gas will be given weight of oxygen gas, which is 1 gram, and its molecular mass, which is 32 gram, into 8.314, value of gas constant. So on solving this, I will get the value of Nr to be 0.26 joule per Kelvin. So C part comes over 0.26 joule per Kelvin. Now talking about part D, if we obtained similar plots for 1.0 into 10 raised to minus 3 kg of hydrogen, would we get the same value of PV by T at the point where the curves meet on the y-axis? If not, mass of hydrogen yields the same value of PVT for low pressure, temperature, plot, region of plot. Molecular mass of H2 is 0.02 U of O2, which is equal to 32 U. So these are the values given to us to utilize in the question. So question is simply it is asked that अगर 1 gram of hydrogen gas हो instead of oxygen, तो जिस पॉइंट पर तीनों कर्व्स मीट कर रही हैं ऑक्सीजन के केस में कितनी वैल्यू होगी सिंपली हाइड्रोजन के केस में कितनी वैल्यू होगी सिंपली इट विल बी नंबर ऑफ मोल्स ऑफ हाइड्रोजन and value of gas constant. So it will be 1. Given weight is 1 gram and it will be 2 gram and into 8.314. This is the molecular weight of the H2 molecule. So when substituting, actually we should write the precise value as provided in the question, which is 2.02 gram. So on solving this, I will get the value to be 6.3 into 10 raised to power 5. Sorry. This comes out to be 0. This comes out to be 4.1158. So this will be the value of NR in the case of 1.00 into 10 raised to minus 3 kg of H2 gas. So next part is if not, what mass of hydrogen yields the same value of PV by T? So if we have to calculate the mass of the hydrogen gas for which the value of NR comes out to be same in the earlier case, which is 0.26. So we just have to calculate the mass of the hydrogen gas required. This will be mass of hydrogen gas divided by its molecular weight into 8.314 equal to 0.26. This implies on rearranging mass is equal to 0.26 into 2.02 divided by 8.314. So this implies mass, the value of mass comes out to be 6.3 into 10 raised to minus 5 kg, which is the required answer.